Everyone else has kind of slowed down and we're getting people come in. So yeah, welcome everybody. We have Bernie talking tonight about Venus, but first I want to hand it over to Dan Beecham because he has some really interesting news I think you guys are going to be very excited about.
Thanks. All right. Hi, Amy, and hi, everyone. Yeah, I'm going to share my screen here and share with you all a presentation that we recently gave to the USDA, the U.S. Department of Agriculture, with a grant reviewer in DC and then local grant reviewers here in the Sayosla National Forest, where they had a land use grant calling for proposals to use areas of the Sayosla, and most of it, there was some $2.5 million actually being offered, and so many of the proposals, as it turns out, were in the purview of forestry and maintenance and trails, and we came with kind of a bold new idea. We heard the announcement for this proposal about a week before it was called for, and I called the grant officer and ran our idea past her, and she loved it. And our idea is that we use our telescopes to draw people to remote sites in the Sayosla where we enjoy the dark skies that are actually the darkest there are south of the Olympic Peninsula on the Pacific coast. And our concept is this, that of course the Sayosla is a national forest, but many of our sites, our dark sites that we like to go to, are out there. And our concept was the idea that we draw people into the forest to see the nocturnal forest and then hear from the Forest Service about the nocturnal forest and its ecosystems. And they're drawn there by us and our telescopes, where we host outreach activities at a nearby site. Of course, all of this is very much in the planning stages, but the idea is this dark sky park to, number one, engage, number two, and hopefully preserve and educate, both on the forest front as well as our activities. And so this is us. I presented this again a couple weeks ago to the review board, and this is just a little bit about the Eugene Astronomical Society and our memberships and various affiliations. I won't detail here, but we've engaged a number of folks here, including Oregon State Parks, in our activities and outreach, showing that we have some reach and credibility. And there are some examples of activities that we've hosted, everything from our massively successful Dexter Star parties, around 300 attendees, to these smaller events that we host in collaboration here at the Science Center. And we have, these venues have shown that telescopes are an excellent way to engage and teach the public and about things they want to know. And one of the places that we as astronomers go is west. In fact, right here is why, because journeying west from Eugene, you can see that some of the dark patches, and actually areas to the south of this as well, that tip of darkness you see under Mapleton, also in the Sayosla National Forest, occupy some of our spots. And so our concept is to first work with the Forest Service and identify some sites, and work with the Forest Service to establish a kind of a curriculum where we would play out the proposal I spoke of before, where there's sort of a dusk setting presentation by the Forest Service agent to an audience about nocturnal ecosystems of the Pacific Northwest and the bats and the lichens and so forth. And then it transitions to a star party that we teach people about the dark skies. And we, of course, lead the whole idea, because it's the Sayosla National Forest, that it is a dark sky park, is a park within this. And so the bigger, picture, my picture that I want, and I think a number of us would like, is a warming hut, like an established site with a gate. And so, some years in the future, if our collaboration serves fruitful, we may actually get to make some gravel inroads and have a warming hut and possibly a gate, and establish a good dark site to host our events. And so we asked for $50,000 to do some of the shovel work for this, and we were granted $3,000 to cover our fuel and probably some planning and a fair amount of socialization and some printing and things yet to be determined in our coming relationship with the Forest Service. So we're excited to collaborate with them. Again, it's all beginning very electronically, but it will be a handful of us driving around out there and identifying sites and looking to the future of outreach with the EAS. So I will pause there, and this isn't really a time to take questions. It's just the announcement on behalf of the board of what we've been up to, but it's really the time to turn it over to Bernie, and we can revisit this in the following in the time afterward.
Mhm.
So I'll go on mute, and thanks for your attention.
So
And
tonight
thanks
have
to the rest. Thanks to the rest of the board for your help with this project. I just tapped everyone on the shoulder. Everyone submitted their slide. Everyone wrote their paragraph, and we all put this thing together in a very short amount of time. And it was really well received, and it really is I think a step in the right direction. I think it could play out nicely for us. So that's what I'm bringing to the meeting today.
On behalf
I think
of
it's going to be a great foot in the door.
I will say thank you very much, Dan, on behalf of the rest of the board for spearheading this project. So thank you.
So tonight we have Bernie Bopp. His talk tonight is The Planet Venus, Rethought, Revised, and Revisited. So
Maybe I'll.
how are you, Bernie?
Thank you.
Maybe I'll
And
pull out
again,
binoculars.
my thanks to the
I
EAS
got my new ones I got a week ago. Period.
for allowing me the opportunity to speak. It's I can summarize what I'm going to say about the planet Venus by giving you the conclusion of the talk, which is basically that the planet Venus is a very deeply puzzling world. It's we'll talk about it. There are many questions that we still have about the planet Venus, which is odd because it's the world that's closest to the Earth, and it should be arguably the best understood, but it's not. And let's see where we're going with this. So let's go to the beginning, and we'll talk about the first observations of the planet Venus by Galileo. And there is a wonderful museum in Florence. That's not the Oregon Florence, but the Italian Florence, which is called the Museo Galileo. And I was there once a number of years ago. They've done extensive renovations to it within the past 5 years or so. It looks great, and if you hit their website, you can even take a kind of a virtual tour of the museum, and I can recommend that. They have 2 of Galileo's telescopes. Now, these are, as I say in the figure caption, lavishly mounted, and these telescopes may well have been presentation instruments, not instruments that Galileo actually used a lot. Obviously, he must have tested them out, but these were probably presentation instruments that were made to the Medici family. Galileo was constantly looking for patronage from the Medicis. This will pop up again a little bit later in the talk. But so these are presentation telescopes. The story of Galileo is a wonderful story. One of these days, there should be an entire EAS presentation about Galileo and his astronomical observations and his physics and his life. An incredible scientist, an incredible astronomer. You may well be aware that Galileo got into trouble because of his observations and his beliefs, particularly his beliefs in the heliocentric model of the solar system, the sun-centered model of the solar system, which he believed, I think, before he even made the telescopic observations that he did, which conclusively showed that, yes, it's a geocentric solar system. So he got into trouble with the church. He got into trouble with the Inquisition. He was brought before the court of the Inquisition. He was put on trial. He was shown the instruments of torture that would be used if he did not recant his position. The instruments were not used, but he was terribly, terribly frightened, as anyone would be. And he did ultimately recant publicly his belief in the heliocentric system. So with that in mind, there's one other display at the Museo Galileo that I'd like to point out to you, which I saw with my very own eyes. I know it's there. And here it is. And you say, wait, what are we looking at here? It's inside a glass case. There are these elaborate containers. There's actually this is a bust, a small bust of Galileo on the top of this one container. So what are we looking at here? Well, look closely. And what we're looking at is two of Galileo's fingers. They were taken as souvenirs. His grave was in one place, and then he got moved to another place. And there were people that sort of took things as souvenirs. I would point out that this one here, the long finger, is Galileo's middle finger. Some say that it points toward the city of Rome. Well, that's merely a rumor, so we'll go on from there. Here's one of his actual, probably a working telescope, and you can sort of get an idea of how big it was. Probably about 1 meter long, I would guess. It has a 2-inch objective. I think that was stopped down as well, so it wasn't a full 2 inches of aperture that he had. But it gave a magnification of about 20. And that's enough to see many things, which he did immediately report in a book, a monograph, if you will, that he published in the year 1610. He actually started making observations in 1609. And what did he see? He saw many stars in the Milky Way. He resolved the Milky Way into thousands of new stars never before seen. He saw the satellites of the planet Jupiter. We call them the Galilean satellites even to this day. He saw the phases of Venus, although he did not report them in 1610. He waited a while before talking about that. He looked at the moon, and he saw that the moon was a world with mountains, that it was rough and corrugated in the same way that the Earth is. It's a world like the Earth, which was not the way things in the heavens were supposed to be. The heavens were supposed to be perfect, and the moon was supposed to be a completely smooth sphere like a billiard ball, and Galileo proved that it was not. He saw sunspots on the sun, and the sun was supposed to be perfect, and yet here are these spots that were on it. So what's going on? The Starry Messenger was published in Latin, scholarly Latin, in the year 1610, just a year after he started his observations. And you actually can see over here, maybe we'll blow it up. You can see that he talks about Medici Sidera, and these are the Medicean stars. What are we talking about here? We're actually talking about the Galilean satellites. Galileo did not call them, he did not name the satellites of Jupiter, the 4 big satellites of Jupiter, after himself. He actually called it Medici's stars. Again, thinking patronage here and thinking rewards, potential rewards from the Medici family. I'm not sure if he got any rewards from the Medici family, but he was out there trying. So we can particularly now talk about the planet Venus. Obviously, this is not what Galileo saw or recorded, but modern photographs of the planet Venus. And a lot of us have looked at Venus, and we know that it shows phases. It goes when it's largest and brightest in the sky. It's actually in a crescent phase. And then we see a gibbous phase, a first quarter Venus, if you will. And the phases are very, very, very obvious. Galileo recorded them, and here are his drawings of planets that he observed in the solar system. The planet Jupiter, just round. I don't think he was able to resolve the the cloud bands in the planet. The planet Mars, his telescope was not good enough to see features on Mars. Perhaps he saw differences in color, certainly with different color of Mars compared to the planet Jupiter. He was not able to resolve the planet Saturn and its rings, although he certainly could see that the planet Saturn was different in shape. He sort of draws it as a kind of an oval here. And then there's Venus. Here's the astrological symbol for the planet Venus, and here are all of the phases that Galileo saw, his own drawings. It shows phases. Galileo immediately understood what this meant. And if you think about it, the Ptolemaic system, the left in the diagram here, that's the geocentric model of the solar system. The Earth's at the center of everything. The sun orbits the Earth. Venus moves around like this in a kind of a special motion, an epicycle, as they were called, an extracircular motion, while it goes around orbits the planet Earth in the geocentric model. And what does that predict? Well, if you think in terms of phases, what that predicts is that Venus should always show a crescent phase. You should never see a gibbous Venus or a first quarter Venus or anything like that. You should only see thin crescents. But if the heliocentric model is correct, as indeed it is, of course, then the planet Venus shows a complete set of phases. And here we get a very extreme gibbous phase heading toward full Venus. Of course, it's very close to the sun and difficult to observe in the evening or daytime sky. But it goes through a complete cycle of phases, which is exactly what Galileo saw. So Galileo concluded the observations confirmed the Copernican system, the heliocentric model of the solar system. Galileo did not publish his observations of Venus. For many years, I thought that he published them in the Story Messenger. That's not quite correct. He published it in another pamphlet, another kind of book that he published in the year 1623. So think about this. This is like 13 years down the road from his initial publication. A couple of things to note about this is that this is not in scholarly Latin. This is not limited to people who could read and understand Latin. It's actually written in the vernacular. So people in Italian. So people could understand it. Many more people could understand it and read it and, draw their own conclusions. And then about 10 years after the Assayer, he published the great book, the book that got him into trouble with the trial of the Inquisition, called Dialogue on the Two Chief World Systems, mainly a comparison between the Copernican system and the Ptolemaic system. It's obvious from the way Galileo writes that he believes that the Copernican system, the geocentric model, is correct, and that's when he got into trouble, lots of trouble. So in a lot of astronomy textbooks, especially from a few years ago, Venus was referred to as the Earth's twin. Well, it's not too often that we see photographs of Venus in the nighttime sky taken from the Earth just by itself. I mean, typically what we see is the crescent moon, it's near sunrise, and here's Venus and the moon. I've taken pictures of that like myself. And Venus by itself is, if you'll forgive me, not terribly interesting. And, there have been a lot of times, I have the feeling many of us have sort of been talking to friends who know that we're astronomers, amateur astronomers. We look at the sky. So they ask us, gee, what was that bright light that I saw in the early evening or early morning sky. It wasn't there a couple of weeks ago, but now it's there and it's really, really, really bright. And probably you have answered many times, oh, it's the planet Venus. Even if you weren't entirely sure that it was, if you had not really paid attention to the nighttime sky or early evening sky or early daytime sky for a while, perhaps because of the weather, you'd be probably safe in saying, yeah, it's just Venus. And, it's not terribly interesting. Now, this is not from not from the ground, but it's a visible light image from an approaching spacecraft, a spacecraft that is heading into orbit around the planet Venus. And, it's not terribly interesting. Is it as interesting as the planet Mars or Jupiter or Saturn? No way. There are no, there's hardly anything to see as far as features in the clouds. We don't see the surface. We don't see the variety of surface features that are visible as Mars rotates. We don't see the cloud bands that we see in the planet Jupiter, the Great Red Spot, and so forth. It's not terribly interesting. And, we see EAS members take pictures of the moon, and they take pictures of Mars, and they take pictures of Jupiter, and they justifiably, sort of send those around, proudly display those to the other members of EAS. And I'm impressed. They look great. To my knowledge, nobody's really, done that with the planet Venus, or if they have, I think it's not usually done because it's not too interesting to look like. It always looks basically the same, aside from the difference in phases. Here's a comparison between Venus and the Earth. There's a little more features that we make out here. Still not features of the surface, features in the clouds, the thick atmosphere of Venus. This is actually a UV image taken by an approaching spacecraft again. A little more structure that we see in variation in the clouds, still no views of the surface whatsoever. So why is Venus the Earth's twin? Well, it's very, very similar in mass and in diameter and in density to the planet Earth. So it's a twin in size, it's a twin in mass and diameter and density. The average density of a world is a very important clue to what the world is made of. And in the case of Venus and the Earth, the average density, sometimes called the mean density, the average density is about 5.5 grams per cubic centimeter. That is an important clue that they're made up of the same stuff, the same material. You might even argue that hints that the internal structure of these two worlds is probably similar as well. Now we can compare this to worlds like the moon, where the average density comes in at about 3.5 grams per cubic centimeter. The compositions of the Earth and the composition of the moon are different enough to explain that density difference. And then when we get to the Jovian worlds, Jupiter has an average density of about 1.4 grams per cubic centimeter, as I recall, obviously made up of stuff, hydrogen and helium, that's entirely different than what we have in the Earth. In the case of Saturn, the density, the average density of that world is 0.7 grams per cubic centimeter, meaning that if you could find a bathtub big enough for the planet Saturn, it would actually float in the bathtub. Thick clouds prevent view of the surface. We talked about that. And then first hint that maybe Venus really isn't the Earth's twin, regardless of what's underneath the clouds and what the surface is like, is that Venus has a extremely slow rotation. It's the world, the planet in the solar system with the slowest rotation period by a mile. It's a 243 days rotation period, and it also rotates retrograde backwards with respect to all of the other worlds in the solar system. That's funny, and by the way, that's unexplained too. Years ago, there was an attempt to explain the slow rotation by a kind of an orbital resonance with the planet Earth. I don't think that's seriously entertained today. One of the things that you can do is you can call up your calculator and take 365, the number of days in the year, and multiply that by 2/3. And what you come up with is 243. Now, is that telling us something, or is it just a numerical coincidence? I suspect it's more of a numerical coincidence than anything else. We'll see. I mean, we need more information about the history of the planet Venus, and certainly about its internal structure too. Oh, and then of course, with the clouds, the clouds of Venus. What are the clouds made of? Well, they're nice white clouds, and if you look at the clouds of the Earth from space, yes, they're white clouds too. And people back in the 1930s and the 1940s and the 1950s sort of thought of the planet Venus as a world covered with water vapor clouds. And maybe it's very sort of warm and wet, a kind of a jungle world. And yeah, lots of science fiction stories written where the planet Venus is such a place. Even Edgar Rice Burroughs did a whole series. He did, of course, all of those many books about the planet Mars, fanciful books about the planet Mars. But he also wrote a number of fanciful books about the planet Venus, Carson of Venus, and you can sort of see that, yeah, there are people living on Venus, and they're, roaming around on very large animals. In some of the stories, not necessarily Edgar Rice Burroughs stories, but in some of the other stories, the animals on Venus are, large dinosaur-like animals. So Venus, you can take a world like the Earth a little bit too seriously, and people were taking it to that extreme. That's not the way things are by any stretch of the imagination. So what a spacecraft show, and really and truly most of our information about the planet Venus comes from spacecraft, in particular orbiting spacecraft. Some landers too, but a lot of what I'll talk about in the talk is going to be from orbiters. And a lot of information from the Magellan orbiter. This was a mission, a U.S. mission that was launched in 1989, went into orbit around the planet Venus, and was operational for about 4 years. Got to the planet Venus in 1990. So think about that. That was more than 30 years ago. And what Magellan did was it mapped the surface, and it used a technique called radar mapping, basically bouncing radar beams off of the surface, waiting for the return echo, which gives information on surface terrain. And I think a wonderful analogy is to sort of think about, we've all seen maps of the Earth's ocean floor with the mountain ranges that are underwater, the tectonic plate boundaries that are underwater. There's a lot that we know about the terrain of the ocean floors of the Earth. It's not obtained by photographs taken from submarines, but actually by sonar maps. You bounce sound waves off of the bottom of the Earth's oceans, wait for the return echoes. It gives information on the altitude of different features. The Magellan orbiter worked just like that, but used radar, and the echoes gave a sense of what the elevations were, and you could get a picture what the topography of the surface was like. Magellan was launched in 1989, taken up in the cargo bay of the space shuttle. All of this did not go to Venus. Actually, here's the big radar dish that was used for the radar mapping. Solar panels not deployed yet that are over here. This is actually the rocket engine that boosted it out of Earth orbit. The space shuttle, of course, was sort of safely away from Magellan before that it was ignited. But that engine sort of took the spacecraft to Venus and placed it in orbit around the planet. And here's a taste of what the topography looks like. We'll see more detailed images in a little bit. So this is a radar image of Venus' surface, and the color coding here, the colors are false colors, but basically the blues are the lowest elevation, and the reds are the highest elevation on the planet. So the gradations in color mean a gradation in altitude on the surface of the planet. The resolution of the Magellan spacecraft maps are a little bit hard to find that out, but my best guess is that they had a resolution of about 100 meters in terms of, not just in terms of altitude, but in terms of location, horizontal position on the planet. So it was a very, very important mission. It taught us a lot about the planet Venus. It sort of raised many questions about the world. So there were other missions too. Pioneer Venus is about 10 years previous to this. That did radar mapping as well, not with as high a resolution, and the Magellan data have superseded Pioneer Venus. Both of those were U.S. missions. And I really want to emphasize, I'll do this more so in the talk, is the tremendous contribution that's been made to our knowledge about the surface conditions on the planet Venus by the Soviet Union. The Soviet Union launched many missions to the planet Venus, and included in those missions are the only spacecraft to make a soft landing on the surface of Venus. The U.S. has never tried to do that. There are missions that are being planned that will hopefully do that, but so far it's all been Soviet missions, the Venera series, that have landed on the planet. And here's a kind of a more detailed map of what the big picture of the surface of the planet Venus looks like. Again, Magellan radar mapping here. And if you look at the scale here, this is a height in meters, and you can see that there are a few places like this, maybe one over here, where the heights are certainly above 10,000 meters. But there's a lot of green that you can see, and a lot of blue. And the height gradations between green and blue are about 1,000 meters, about a kilometer. There's other information that we'll show here. For example, this area here, what are these indications? Venera 9, 10, 13, 14. All of these are some of the Soviet probes that landed on the surface. 9, 10, and 13 and 14 actually sent back pictures from the surface that we'll show in just a moment. So what do we see? What's the sort of big picture of this? Well, there are two, I guess we call them continents on the planet Venus, and features on Venus are named after, by convention, are named after female people or goddesses. So here's Aphrodite Terra over here, and you can see that's pretty high. I mean, that's 5,000 meters and higher stuff over here for the most part. And there's another large continent-like area here that's Ishtar Terra. There's a very high peak over here, which defies convention, because that is, let's look at it a little bit more closely. There's Maxwell Montes, Mount Maxwell, and the Maxwell that's being referred to is not, it's James Clerk Maxwell of Maxwell's equations fame, not a female personage, but that Maxwell Montes was named early on, and I think the name just stuck. They haven't changed it to a feminine name, so it defies the convention a bit. So there are only a couple of large elevated regions on the surface of Venus, and the Venera landers again are over here for the most part. There are a couple of ones that are over here. We'll talk about those in a bit. They didn't actually land on the surface, but Vega 1 and Vega 2 deserve comment, and they will get comment. But here's really something that's very, very strange. The maps from the Magellan mission show that 80% of the planet Venus is flat to an altitude of 1 or 2 kilometers. And again, compare that to the planet Earth. Think about the very great gradations in terrain that we have just here in the state of Oregon, or in the continental United States. There are much greater variations in altitude, and it is not the case that 80% or even close to it of the surface of the planet Earth is as flat as this. So we've got flat terrain over more than 3/4 of the entire surface. So another example of how Venus is not the Earth's twin, terribly, terribly different. And of course, the question is, how did this happen, and why did this happen? We'll see where we can get with this. So there have been many Soviet missions. There were many Soviet missions to the planet Venus. It was, I'm not quite sure why, but maybe the logic there was that the American missions to the planet Mars were very successful. So let's sort of, the Soviet space program decided to concentrate on the planet Venus. Another reason, I think, is that, as we are aware from the recent missions to Mars and the soft landings, it's tough to land on Mars. I mean, you can't do it just with retro rockets. You can't do it just with parachutes. You need both, and that particular combination is technologically tricky. But here are images from the Soviet landers. 4 Venera landers actually made soft landings on the surface, sent back surface images. There were at least a few missions that were failures that crashed into the planet. These were landed by retro rockets on the surface. Well, no, take it back. These were probably parachute missions because of the very thick atmosphere. But what are we looking at? Well, okay, here's the skirt, the bottom skirt of the Venera lander. This is, I believe, a lens cap or a covering for the lens of the camera that's been ejected. And, what do we see? Well, we see flat rock. Not unexpectedly, they landed in a pretty flat region of the planet, and 80% probability that they would do that. The rocks appear to be volcanic in origin. We'll talk more about that. Here's another image that was sent back by the Venera 13 lander, 1982, one of the last Soviet era missions. Here's the lens. Here's another lens cap again. Same kind of lander, same kind of mission. This over here is a sort of a series of color bars to allow calibration of the color images, but the same kind of thing. In both cases, the terrain looks very similar between the two sites. Volcanic material on the ground. Oh, now wait. Why am I showing an image of Ingenuity on the surface of Mars? We're talking about the planet Venus, aren't we? Well, Ingenuity has been a very successful. The little helicopter has been, a wonderfully successful mission. It has been really turned out to be a valuable part of that Mars lander mission, even though it was basically a proof of concept kind of experiment. So, and many people said, "Oh, wow, this is wonderful. This is the first time that a machine, a device has sort of explored the atmosphere of another terrestrial world. How wonderful! American ingenuity at its best." Well and good, and it is a tremendous achievement. I don't want to minimize that, but it wasn't the first, and sort of forgotten now. I think is that the Vega probes. There were two of these. These were deployed in the early 1980s by Soviet space missions to the planet Venus, and these were balloons, free-floating balloons that were deployed and floated around in the Venusian atmosphere. They lasted. They were specially designed to withstand, as we'll see, the corrosive effects of the atmosphere of the planet Venus. And they lasted for a couple of days. They sent back data about temperatures, compositions, pressures in the atmosphere as they floated around. I don't know exactly how high above the surface they were, but they lasted for a couple of days. So these were Ingenuity, a great mission, a great little helicopter, was not the first explorer of a planetary atmosphere. It was instead the Soviet Vega balloon probes from 40 years before Ingenuity, but people have probably just forgotten that. So the landers, the two images from the two different landers that I show, the four landers, none of the four landers that sent back surface images lasted very long. That was to be expected because surface conditions on Venus, if we ever wanted to think about Venus as the Earth's twin, now we have to throw that completely out the window. The atmosphere of the planet Venus, there's no water vapor clouds. Instead, the clouds, those whitish clouds, are sulfuric acid clouds, nasty stuff. And in fact, the Vega probes were specially coated to resist the sulfuric acid in the atmosphere of the planet Venus. Most of the atmosphere, though, is carbon dioxide, very thick CO2 atmosphere. So you've got an incredible greenhouse effect on this world, and the surface temperature is about 900 degrees Fahrenheit. Now that's hot enough to melt lead. So the Venera landers didn't last very long. They did not transmit data back to the Earth for very long. I think the longevity record for one of the landers is 2 hours, and then the electronic components were fried. And then finally, if they withstood the temperature, they could very well have been crushed by the atmospheric pressure. That atmosphere is so thick that the pressure on the surface of Venus is 90 times Earth sea level pressure. It's the equivalent of being like, oh gosh, a kilometer or two underneath the surface of the ocean, comparable pressures to that. So the kind of Venus is not a world like the Earth by any stretch of the imagination, except maybe for size and average density. But it is really a hellish world. I think that's not an original term with me. It's something that is very, very inhospitable. But the important thing is now to sort of think about, okay, how did it get that way? And what more do we know about the terrain and about the surface features? Now, one of the things that we've done in the last couple of talks that I've given is pause in the middle to take any questions that there might be. So I'd like to take a brief pause now. We're about halfway through, and we'll go on with more detailed look at surface features. But if there are some immediate questions that I could answer right now, go for it.
I do have a couple of questions that were put in chat earlier.
Sure.
The first is, what is Venus's year? How long does that last?
About I think it's 225 days. So it rotates. The day on Venus is actually longer than the year. The orbital period is 225, and the rotation period is 243.
Do we ever see Venus when full, either above or below the sun's position?
Yes, or very nearly full. Yeah, you could. I mean, it's an issue of spotting it and being very, very, very careful that you don't point your telescope toward the sun. Jerry is. I know Jerry is. Jerry may well have seen it. We can ask him if he's actually seen Venus in a full phase. The difficulty is, you're in a very bright daytime sky. There's a lot of glare from the sun. So what do you think, Jerry?
I have not done it, but I think Frank Kapansky did it just a week or two ago.
Okay.
Yeah, so it's been done locally, but not by me.
Galileo's drawings indicate that he got pretty close. And by the way, the sunspots that he observed, in case you're wondering, he projected them onto a piece of paper or parchment, so he was able to map and actually draw the sunspots on the sun via projection, which is the safe way to do it, a safe way to do it.
Quick note, Jerry, you were there when we observed Venus in the daytime at a Solar Sunday event. Remember, Leticia pointed it out by eye, and you put your telescope on it. It wasn't in full phase, but
Right.
observing Venus in the daytime is a thing you can do. And of course, that's the only way you'll catch it in full phase. But you have done that.
One of the cool things about observing Venus in the daytime is once you know where it is, you can spot it by naked eye.
That's right.
You don't
can't
need a
unsee it.
telescope, but you really have to know where to look.
Yeah.
There is also a comment in the comments in the chat that the two Venera images look very similar, like just rotated 90 degrees.
No, I don't think so. Look at the lens caps. Look at the lens covers.
Yeah.
These are different missions. I know this is Venera 13. I don't know which Venera mission this is. The lens cap has a different orientation here. Yeah, I agree. They look very similar, and I think that's indicating that the surface terrain, the surface geology, if we can use the word, is very similar for these two landing sites. They were not terribly far apart on the planet, but I'm sure they were separated by hundreds of kilometers.
We also have a question: how old is Venus? Is it older or younger than Earth?
Well, I mean, all the planets in the solar system formed at the same time, and that would take us back to about 4.6 billion years. I mean, the sun and all of the planets are coeval, as they say. So they have the same age. After that, it's clear that the geologic history and the geologic activity on the planet Earth and the planet Venus diverged. We'll talk more about this, but unanswered still is, why did they diverge? If they have similar mass and similar composition, and we think similar internal structure, shouldn't the geologic activity be the same? But there's something very important that we're missing, and we don't know what it is yet.
We have one I know that you're probably going to talk about later, which is if there are any upcoming missions to Venus.
Yes, and that'll be the last couple of slides that I have. So maybe let's press on, and we'll be talking.
I have two more real quick.
Oh, okay, sure.
Does Venus have a magnetic field?
No.
And are there many craters on Venus?
We'll get to that.
Okay, that's it for chat.
It depends on, I will be mysterious, and it depends on what you mean by many. But we'll talk about that. There actually a lot of interesting information and puzzling information about cratering on Venus, which we will indeed talk about. Okay, so let's sort of head on and see what there is to see. Okay, we're going to look now at a more detailed view of surface features, and we'll talk about impact craters. We'll talk about volcanoes on Venus, because the Magellan spacecraft, with its resolution, spatial resolution of 100 meters or so, obviously can see more detail than what I've shown so far. So, what's there to see? Are there impact craters? Yeah, there are. Now, Venus has a very thick atmosphere, and you might say, well, wait, doesn't this kind of shield the planet from any impacts? No, it certainly shields it from chunks of rock, meteors that would be, gosh, I'm sort of guessing here, a few meters across. If it were a few meters across hitting the atmosphere of the Earth, it might well make it down to the surface. But on the planet Venus, with its very, very thick CO2 atmosphere, those would burn up in the atmosphere. Nevertheless, there are impact craters with diameters of tens of kilometers that we can see on the surface. And this, like this one over here on the left, this looks very much like, if you said, oh, this is a crater on the moon, you could probably believe it. These are ejecta over here. The difference in brightness here is really a reflection of difference in composition or difference in particle size, which is produced by the different way that the radio waves are reflected. So it's not so much a color difference as it is the sense of the way that the radio waves or radar waves from Magellan actually reflect back to the surface. Namely, it means that the material here and the material here are rather different. And this is ejecta from an impact. And there are, well, how many craters are there here? There might actually be 1, 2, 3, 4 impact craters here. And you might say, well, isn't it weird that 4 of them are all here at once in the same place? Again, these are large impact craters. They're at least a few kilometers across. I suspect that what's going on here is that it was a large chunk that broke up in the atmosphere, perhaps into 4 different pieces that landed in close proximity to each other. So what else do we see? We see a lot of this. We see indications that the crust of the world has been stretched. That there have been motions, crustal motions, that have sort of caused these ripples, these channels on the surface. You could even imagine, look up over here and look up over here and here, and we may see very similar kinds of things to this. So a lot of that is seen on the surface of Venus. And Then there are features that are a little bit unusual. There are some features like this on the Earth, I understand, but not very many. There's quite a few of them on Venus. These are called pancake domes, and it might look like they're circular sort of depressions. I think that's a trick of the perspective or the way that that this has been sort of artificially kind of lit up by the radar. These are actually dome figures, and I think you can even make out. Let's take a closer look. I think you can even make out that there are fracture patterns that we see here. So all of these are domes. They're basically lava domes. So there has been an upwelling of lava from not to sort of cause a volcanic flow, but just to sort of bubble up parts of the surface. So pancake domes are surprisingly common on the surface of Venus. They exist on Earth, but my understanding is that they're pretty rare. Oh, and then another biggie and important thing. Do we see crustal plate boundaries? Do we see things like a San Andreas fault? Do we see mountain ranges that have been produced by the collision of crustal plates? No. There's no clear sign of plate tectonics on the planet Venus. Plate tectonics, as you are aware, is a very, very big thing on the Earth. It's the driver of geologic activity on the Earth, nearly all of it. So that we have one of these, another Earth's twin paradox. It's a world that is made of the same stuff as the Earth. It's the same size as the Earth, same mass as the Earth, but no clear sign of plate tectonics. Very puzzling. So what about volcanoes? Yeah, we've got volcanoes on Venus. You can take the Magellan radar map and actually get enough information from the radar maps to get sort of tilted on its side and get a kind of a 3D perspective of what the different heights are of different features. And here's Maxwell Montes, Mount Maxwell. This is the highest point on the planet Venus, and this is a volcanic peak. It is not, as far as we know, an active volcano. Of course, we haven't really observed it for very long. And this is the peak that rises up to an altitude of about 12,000 meters or so. So it'd be well over 30,000 feet, higher than Mount Everest on the Earth. Over here, as an added bonus, there's an impact crater. And this, again, following the convention, this is named after a female personage, namely Cleopatra, 100 kilometers wide. By the way, the vertical scale here has been exaggerated to just, make it easier to imagine that we're looking at a very, very tall peak. So that's definitely a volcanic peak, kind of like a shield volcano on the Earth, like Mount Fuji, perhaps, or like Mount Olympus on the planet Mars. So we're looking at a large volcanic feature. We certainly see lava flow channels. This is about 2 kilometers wide over here. I don't know exactly how long it is. You could hundreds of kilometers, I'm sure. So this is a big lava channel, but clear sign of volcanic activity and lava flow across the surface. Here's another volcanic feature, again with exaggerated height, stretched height. It's called Matmons. I don't know. I can't recall. Mat, I think, is some kind of goddess, but I don't know precisely what culture that is from. This is about 8 kilometers high. Again, Maxwell Montes is about 10 kilometers high or 12 kilometers high. There is some suspicion that Matmons could be recently active. there are some tantalizing observations that have suggested the possibility of volcanic gases that have been released into the atmosphere of Venus. They weren't there before, then all of a sudden we detect them, and then they kind of spread out and dissipate. Might be an indicator of volcanic activity. There are even some observations that indicate in the infrared that indicate that certain areas on the planet near volcanic peaks might have been warm. Lava flow again. So volcanic activity is a big thing on the planet Venus. Planet-wide, there are 1,500 volcanoes. Now, the first thing that we should ask is, okay, let's compare that to the Earth. How many volcanoes are there on the Earth? We're not talking about active volcanoes, but we're talking about just peaks that we know were formed via volcanic activity. On the Earth, about 1,300. And on Venus, 1,500. So they match up pretty closely, except, look at the last two words. Planet-wide, the 1,500 volcanoes on Venus are evenly distributed across the surface. That is very, very, very important, because on the Earth, volcanoes are not evenly distributed. We know that volcanoes occur preferentially. Yes, there are some exceptions, but preferentially, volcanic activity occurs near crustal plate boundaries on the Earth. On the planet Venus, no sign of crustal plate motion. Still, a large number of volcanoes, but evenly distributed. So volcanoes have erupted across the planet Venus, but in a uniform way, not near crustal plate boundaries. How do you do that? And it is not at all clear. And, there are things that get even more puzzling. We're going to get to that. Well, I need to talk about crater counts. I've done this before, but it's a very powerful tool to talk about the ages of crustal rock on terrestrial worlds. Now, the best way, of course, would be to go to the planet, bring back a sample, do the radioisotopic analysis, and get the exact age, or something close to the exact age, of when the rock solidified. We have done that for the case of the Earth's moon, but that's the only other world in the solar system where we've done it. Be nice to do that for Mars, and before too long we'll do that. Sample return missions will help. But if you look at the Earth's moon, and we all do, obviously there are two kinds of terrain that we see on the Earth's moon. There are two kinds of terrain that Galileo saw. He saw the lunar highlands, which he knew were mountainous and rocky and not a uniform elevation. And there are also smoother, darker regions on the Earth's moon. And Galileo himself called them maria. We still call them maria today. Maria, of course, is the Latin word for seas. Galileo thought that they were bodies of water, and that he was looking at an Earth-like world with mountains and with bodies of water on its surface. Not true, of course, but this again makes the moon very much a world like the Earth, which is yet another reason why Galileo got into trouble with the Church and the Inquisition. I like this diagram a lot. In fact, I only sort of stumbled across this in making up this talk. Let's look at it more closely. This is rate of crater formation on the y-axis, and time on the x-axis. All the worlds in the solar system, again, formed 4.6 billion years ago or so. There was obviously a period of intense cratering as the kind of leftover stuff, the planetesimals that made up certainly the terrestrial worlds, sort of accumulated and grew and ultimately became Mercury, Venus, Earth, and Mars. So, but during that period of intense cratering, The surfaces probably were completely molten. They were being bombarded continuously, and they started off hot, and they were heated up even more by the impacts. So that era is lost. There certainly is crustal rock, not much of it, very little of it, that we can find on the Earth that goes back to a time in excess of 4 billion years ago. And that's the oldest crustal rock that we see. Similarly for the moon. Now, again, the astronauts brought back rock samples from the highlands and rock samples from the Maria. They have different ages. And the highlands come in 4.2, 4.3 billion years old, whereas the Maria come in much younger than that, 3.8, 3.9, maybe 4 billion years old. After that, on the moon at least, nothing much has happened. Yeah, recent craters, Tycho, Copernicus, probably formed perhaps 1 billion years old. And there are impact craters still being formed today. I think that some of the orbiting spacecraft around the moon are even seeing new impact craters that are being formed today. But not very often. The rate of crater formation has really dropped off since the beginning. But by looking at the amount of cratering that we see on a world, we can tell, or at least have some clue, as to the age of the surface rock. And I mean, think about here's Meteor Crater in Arizona, outside of Flagstaff, and Meteor Crater is is it how big is it? Well, it's about 1 mile in diameter, as I recall. It's an impact of a meteor about the size of a house that impacted about 50,000 years ago. Obviously, it had enough kinetic energy to dig out a much larger hole than just the size of a house. It's not going to last very long. There'll be erosive forces, wind and water in particular. And you say, well, it doesn't rain that much in Arizona. Yeah, but if you wait for 1 million years or 10 million years, Meteor Crater is going to be gone. It's a tourist attraction simply because impact craters on the Earth are so very rare. The surface of the Earth is being constantly resurfaced by wind erosion, water erosion, and crustal plate motion, volcanic activity, plate tectonics. And that's even true for the planet Mars. Let's sort of zoom in on that. And here is, this is actually topography of the planet Mars with the same kind of color coding, with blue being the lowest elevations and red being the highest. Here's Olympus Mons, which is something like 50,000 feet high. You can see it's 20, something on the order of 20,000 meters. Here are the Tharsis volcanoes over here. And the blue is relatively low in elevation. The orange and yellow in between. But look, there are regions on Mars that are very heavily cratered, much more heavily cratered than any area on the Earth, and things that kind of remind you of the way things look in the lunar highlands. But there are also areas here that are quite smooth and flat that kind of remind us, they were not formed in the same way, but kind of remind us of the much younger lunar Maria. And certainly this area of Mars with few craters is much younger than this area of Mars with many impact craters. So crater counts, as they are called, is a good clue to finding out what the ages of various portions of the surface are. If we look over here at the Tharsis Ridge on Mars, the volcanoes, I mean, even here you can see that the surface is relatively smooth. There's no sense of the many impacts that we have over here and relatively few over here. So the volcanoes, they're newer, they're younger than the heavily impacted areas. How young are they? Well, it'd be nice to take go back there and get a sample, bring it back to Earth. Some people say well, these might be 1 billion years old. They might be younger than that or older than that. We don't have a good handle on that. By the way, MOLA is the Mars Orbiting Laser Altimeter. And this uses a technique just like Magellan, only with optical visible light. Well, I can't swear that it's visible light, but you basically take a laser beam, you shoot it down from the spacecraft, it bounces back, you can check the arrival times, you can get a detailed surface map of the planet Mars from that same kind of technique, which is radar mapping on Venus or sonar mapping for the ocean bottom of the Earth. Okay, so what have we got? What have we got for impact cratering on Venus? Here we go. Okay, here's again, this is a Magellan map. The coloring, the color coding is similar, may not be exactly like what we saw before, but all of the dots, and you can see sort of a key over here, crater diameters that are dozens of kilometers, the largest ones, and at least 10 kilometers or so for the smaller ones. And here's the distribution of craters impact craters, that is, that we see on the planet Venus. So what do we see? We see about 1,000 impact craters on Venus. Now, how many impact craters do we see on the Earth? This has been, there have been a census, careful census has been made, and 128 impact craters on the Earth, about 1,000 impact craters on Venus. But if you take this crater distribution and sort of say, okay, where's the young terrain and where's the old terrain on the basis of crater counts, like we can do on the moon, like we can do on the surface of Mars, the impact craters on Venus are randomly distributed. This has actually been mathematically tested. You can take the locations, the longitudes and latitudes of these craters, and actually test the distribution and see if there's any kind of grouping or clumping of these impact craters. It's randomly distributed. Now, what that implies from this kind of crater count analysis is that the surface of the entire planet has a uniform age. We can't say that about the Earth. We can't say that about the moon. We can't say that about the planet Mars. But the surface of the planet Venus has a uniform age. What is that age? We wish we had samples. It'll be a while before we get samples, I'm sure. But the best estimates, I've read estimates that say 500 million years to 800 million years old. But everything on Venus, every surface feature that we see on Venus was formed within 500 to 800 million years ago. Let that sink in for a moment. It's, that's a very, very, it's telling us something very, very, very important. We wish we understood how that can happen and why you can do that. It implies that, we've got volcanic activity. We've got a lot of volcanoes on Venus. We've got signs of volcanic activity. And yet with the analysis from the crater counts, apparently 500 or 800 million years ago, or sometime in the past, there must have been incredible planet-wide volcanic eruptions that completely resurfaced the world. How can you do that? How did Venus pull that off? Without plate tectonics, and plate tectonics produces localized volcanic activity, not planet-wide volcanic activity. We don't know. We don't understand. And this is, to my mind, this is one of the biggest puzzles of the planet Venus. How do we get volcanic activity without plate tectonics? And how do we get planet-wide volcanic activity? We don't know. Well, no talk on Venus would be complete without mentioning phosphine. You may recall that this was in September 2020. And I know that Jerry made some comments about this to the EAS listserv. I went actually and looked at read the original papers about phosphine. Phosphine is just pH 3 phosphorus and 3 hydrogen atoms, and there's a kind of molecular picture of it. I got very excited about this. I think Jerry was sort of excited too, because number one, the observation looked very good. I read the paper. The astronomers in question had taken their time. They'd been very careful. They had taken several years, 3 or 4 years, to make a series of observations that presumably indicated that they had detected phosphine in the atmosphere of the planet Venus. Phosphine is a biosignature. It's produced by decay of organic material. In other words, biological decay, anaerobic bacteria release phosphine. There are no other chemical reactions that really produce this. Could you say, well, could it be emitted by volcanoes? And the answer is no, it's not. Are there other interactions, other chemical processes that could produce it? Here on the Earth, the answer is no. So it's a biosignature, and people got really excited. Gee, maybe there's some kind of life, not on the surface, not in 900 degrees Fahrenheit, but maybe something in the atmosphere. High enough in the atmosphere, the temperatures would be considerably lower, the pressures would be lower. Maybe, we'll see. The observations were not visible light observations. They weren't infrared observations. They were instead millimeter radio wave observations. You're looking at particular, I don't know if it was a vibrational transition or a rotational transition of this particular molecule, but they made their first observations. The team that released their paper in 2020, they made their first series of observations from the James Clerk Maxwell telescope. That's on the summit of Mauna Kea in Hawaii. So it's a big radio dish observing at millimeter radio wavelengths. They had very interesting results that they kind of a 3 sigma observation that they were not entirely convinced was credible. So they took their time and they did follow-up observations at ALMA, ALMA, the Atacama Large Millimeter Array. This is in the high desert in Chile, very dry site, very good for observations of this sort. And the ALMA array is much more sensitive than the James Clerk Maxwell telescope is for these kinds of observations. And here's the data from their paper. And okay, we can blow it up a bit, maybe see here we go. Now, okay, so here's basically they're looking at the absorption spectrum at millimeter wavelengths. And here's the particular feature that they've observed, and that says Venus frame velocity kilometers per second. Think of this as wavelength, if you will. And they're looking at a feature, and is it convincing here? By the way, I'm not quite sure what the difference between the solid line and the dashed line is, but anyway, there's a feature here that is interesting in the JCMT data, but is it good enough to publish? They didn't think so, and I wouldn't think so either. But instead, here is the feature observed by ALMA, and this is very convincing. I mean, they refer to it as a so-called 5 sigma, 5 standard deviation observations. And look, I was convinced. I read the paper and I thought, oh, this really looks interesting, very exciting. Subsequently, people have said, whoops, wait a minute, they haven't detected the phosphine feature. Instead, they've detected another feature that's due to, I forget, sulfur dioxide, I think. And others have said, well, the other thing that they didn't account for was that the ALMA dishes are really calibrated to look at point sources, and Venus is not a point source, so therefore the calibrations could have been a little wonky. It's now kind of up in the air, but we'll see. Anyway. I don't think anyone now can say, oh yeah, sure, we've detected phosphine in the atmosphere of Venus, but it's intriguing, and maybe there'll be follow-up, and in particular by new spacecraft missions. Okay, the good news is that there are no fewer than 3 spacecraft missions that will be headed toward the planet Venus, and indeed it will be the first U.S. missions to the planet to do things of this sort for 30 years, more than 30 years. So one of them is called Da Vinci Plus. The other one is called Veritas. By the way, both of these are acronyms, clever acronyms that really describe what the kind of instruments that are on board the spacecraft and what they'll look for. I can't remember what the acronyms stand for, and I have the feeling that if I told you, everybody would forget after a couple of minutes, so I'm not even going to bother. But Da Vinci is a scheduled for launch in 2029. Now, these could slip, so let's say they're roughly 10 years down the road. Da Vinci is an atmospheric probe and an orbiter. Now, the atmospheric probe thing, to my mind, is the most interesting thing, because it really is the first U.S. atmospheric probe in a long time. I mean, there were no soft landings by American spacecraft, U.S. spacecraft on the surface of Venus. That is entirely the domain of the Soviets. It's nice to see the Americans sort of trying it this time. It will do imaging and atmospheric sampling during the descent. I'm sure the descent is going to be a large parachute. So there'll be images taken on the way down, and also samples of the atmosphere, the cloud layer, the atmosphere during the descent stage. They will check for phosphine as they head down through the atmosphere. You never know, do you? If they do indeed detect it, that would be quite a pleasant surprise. Who knows? But they do intend to check for it. I'm not sure they believe they'll find it, but they certainly want to check. And it will make a soft landing on the surface. How long it will last at 900 degrees Fahrenheit and 90 atmospheres at the surface is anybody's guess. It will not be one of those probes that sort of has treads on it that crawls around. Obviously, there won't be time. If it lasts for more than a couple of hours, it'll be a big deal. But nevertheless, that is a very, very interesting mission, and again, look forward to its results. Veritas is launched 2028. That, of course, could also be take another year or two if things are delayed a bit. But Veritas is going to be basically a kind of a super Magellan. It is a radar mapping mission. And here in Artist Conception, it's sort of making another detailed topographic map of the surface of the planet Venus. This is just an orbiter. There'll be no atmospheric probe. So the surface mapping that it will do, and you can get 3D images from this, as we saw from the Magellan data. 30 meters horizontal resolution, 5 meters vertical resolution. So on the average, maybe at least half a dozen, maybe 10 times better resolution than Magellan. And let's face it, the history of observations, either radio observations or visible light observations or any kinds of observations, is when you bump up the resolution, the ability to see detail by a factor of 10, you always see, wonderful stuff. They also intend to carefully monitor the orbit. There'll be instrumentation that will be able to measure the gravitational field of the world to great accuracy. And this is going to be giving us a handle on the internal structure and possibly that really puzzling sense of why, how did Venus get completely resurfaced 500 or 600 million years ago? Like I said, that to my mind is the most puzzling aspect of the entire world. The next mission, which is going to be, let's see, when is the launch for this? This is going to be 2032, so a little bit later than the two U.S. missions. This is a mission by ESA, the European Space Agency, and Envision is probably an acronym there, but V probably stands for Venus, as it does in Veritas and Da Vinci. After that, I don't have a clue as to what the acronym stands for. But this too is going to be an orbital mission, no lander here, no atmospheric probe, high resolution radar mapping, similar to the US mission. The radar mapping hardware is actually going to be produced by those wonderful wizards at the Jet Propulsion Labs in Pasadena. So I'm sure it'll be very good. But in detail, I don't know how different it will be from Veritas. There's not a lot of information available online because these missions were all announced sort of in late fall of 2021. So there's not a lot that's up yet about them. And, they haven't started building them yet. Now that they've got the funding for them, they'll start to construct them, but still things are a little bit up in the air. Now, another nice thing about Envision is that it'll do spectroscopy. It will actually analyze the light being reflected off the clouds and coming through the surface of the world, and they'll be looking for evidence of volcanic eruptions. Again, I mentioned that there's the suspicion that there have been volcanic eruptions, but and I'm not talking about the 500 to 600 million years ago. I'm talking about the Mat Mons possibility, where the volcano might have erupted very recently within a few decades. So they'll be looking for evidence of volcanic eruptions by gases that are typically emitted by volcanoes on the Earth when they are erupting. And yes, there'll be detailed mapping of Venus' gravitational field, again with a clue to trying to decipher the internal structure. I apologize. I apologize for ending things like this, because we're ending on a note of, wait, what does it all mean? And the answer is we don't know what it means yet, but I'm hopeful that 3 new spacecraft missions will put a dent in that, and that in 10 years, son of a gun, 10 years. Whoa. Okay, in 10 years that I can come back and do another EAS presentation, God willing, on the information that we've obtained from the new spacecraft missions. So again, thank you very much. I appreciate you're allowing me the honor to talk to you this evening. And if there are additional questions, and I suspect that there are, I'll be happy to attempt to answer them.
Karen put in chat that the wavelength in the chart that you showed would correspond to rotational and not vibrational.
I'm fine with that. I don't know what kind of I don't know what kind of a molecular transition. I think I read it once in the paper, but I've forgotten. That was a year and a half ago.
And Dan, you asked a question about incoming meteors. I know you're not shy. You want to just speak up? Oh, you don't have your, okay.
There, wait, hold on. This might
Yeah.
work. Hi. It usually just makes a lot of echo. Yeah, I was wondering about the relative speed of incoming objects as they approach Venus versus the Earth. You know, are they getting fast enough? Is the difference fast enough as they approach the sun that they hit Venus harder? And I was kind of also curious about
I don't think so. You're imagining something. An object sort of swinging past the sun in a kind of a parabolic way, and then impacting Venus. I don't think that happens very often. I mean, most of the chunks of rock that we have are sort of floating around the sun in roughly circular orbits, and then the orbits of the rock chunk and a world happen to coincide, or they are perturbed into a collision with the Earth or Venus. So I think that the impact speed for Venus and the Earth would be very comparable because they have similar mass.
Anyone else has a question? Speak up.
You already answered my other two. Thank you.
Oh, nice. I can kill two birds with one stone.
Great talk.
Bernie, I have a question
Sure.
about the magnetic field. Is that because there's no magnetic field because the planet rotates so slowly relative to the Earth?
Well, people used to believe that, and indeed, I remember talking about that and I'm using that logic to talk about that with my introductory astronomy classes, and saying, "Oh, this is dynamo fields need you need a magnetically conducting material inside the planet, and you also need relatively rapid rotation." I mean, the planet Jupiter rotates very rapidly, has a very strong magnetic field. Earth has a strong magnetic field. Venus doesn't, and it's because it doesn't rotate so rapidly. My understanding is that you can model this, and sort of it has been modeled. And indeed, if you have enough material, enough sort of convective material in the center of Venus, even a 243-day rotation would still produce some magnetic field. And we detect, as far as I know, zero.
So is it still?
There are still unanswered questions. It's still puzzling. Well,
Yeah.
I mean, if you if you come away with nothing else from this talk, you please remember that please know that Venus is deeply puzzling. It is. There's a lot of things that are puzzling to me as an astronomer, almost to the sense of infuriation. This shouldn't be happening. This shouldn't be the way that a planet behaves.
But we do presume that the core is nickel iron nickel.
We argue from similarity with the Earth, and
Right.
we say, okay, look, this is the way it is in the Earth, and the average densities of the two planets are very, very close. Therefore, it should be the same.
Right.
But if that's an argument that might not be a terribly strong argument, might be a relatively weak argument. I don't know, but let's wait for the spacecraft to give us more information on that.
I'm still kind of blown away by the volcanoes without plate tectonics. I can't get over that part.
You got me. Although I would point out that there are volcanoes on Mars with plate tectonics too. I mean, there's no real sign of plate tectonics on the planet Mars, and yet we have those huge volcanoes. But there aren't many of them. I mean, there's a handful of large volcanoes on Mars. There are, what did I say? 1,500? Yeah, 1,500 or so volcanoes on the planet Venus, which is a lot more. And, yeah, you're right. How do you get that many volcanoes without crustal plate motion? There are exceptions on the Earth. There's hotspot volcanism on the Earth, which occurs not really near a crustal plate boundary. And the Hawaiian Islands are an example, as I recall, of hotspot volcanism. There are still parts of the Earth crust that might be a little bit thinner that would allow laval upswells. And the volcanic activity that we see in the Hawaiian Islands are I believe I recall this hotspot volcanism. Relatively rare, though. I mean, the vast majority of volcanic activity on the Earth is near crustal plate boundaries.
Yeah, because even with the Hawaiian Islands, you've got the lava, and then you've got the plate floating over it and coming that, and that's how it makes the island.
Yeah, and there's certainly been motion. The fact that we can think of the Hawaiian Islands as a string of volcanoes. Well, that that in itself is indicative of crustal plate motion.
Would the volcanoes where are rode away similar to the way craters have on Earth?
Say again, please. I didn't hear the first part of your question.
Would the volcanoes on Earth erode away very similar to the way that the craters erode away on Earth? So maybe that's why there's not such a presence of them?
Well, certainly volcanoes erode, mountain ranges erode too. So there are erosive forces on the Earth that simply do not exist on the planet Venus. Wind and water erosion. By the way, the surface winds. You say, well, how about wind erosion in a thick atmosphere? The surface winds on Venus, at least as measured by the Soviet landers, were not very strong, and I think the same thing was confirmed by the Vega probes, that the balloons that floated through the atmosphere. So we don't have a lot of wind erosion as far as we know. Many puzzles. I'm sorry. I wish I knew the answers to this, but I'm waiting for the spacecraft.
I know you have more questions.
Oh, you remarked earlier that, we don't see much in the way of EAS photography of Venus. And I can also mention, it's certainly not a target for observation either when we go out. It's blinding. You can't even dare to look at it. It's like staring into the oncoming headlights.
And
you lose sight in that eye for 40 minutes.
It's not interesting. I'm the first to admit that from a ground-based observational point of view, optical observational point of view, the only thing that's interesting is the faces. And after that, you see them once, you say, okay, well, that's enough. I mean, if we look at the planet Mars, there's a lot going on the planet Mars, a lot going on the planet Saturn, a lot going on the planet Jupiter. Even the moon is, the phases there are interesting phases. We can see different things at different phases of the moon. On the planet Venus, we see the same thing at all the phases.
And there's no Elvis.
Oh, no,
Elvis, right.
Yeah. I think that's safely observed, though. Venus does offer a daytime viewing opportunity that you don't often, see. I've only done it the one time, but it is something that'd be kind of fun to host one day in the future on a solar Sunday. Because I
agree.
By the way, can you see the other planets? Could you see Jupiter, for instance?
I think if you had, well, it's a problem in surface brightness, obviously. I know that you can. I know that if you know exactly where to look, especially if you're looking at red stars like Betelgeuse, for example, you can see those in the daytime. But you've got to have, your pointing has to be dead on the money.
That's fine. No, actually, the pointing of just a go-to telescope, but out of the box will take you right to
That's cheating.
center of it. No, but I'm saying, like, but if they make observational targets, I want to know if they really are visible.
Actually, yeah.
No, Venus certainly is. Is Jupiter? Because
Jupiter is definitely visible, and we did that during the day, a decade or so ago, when it was
that's
near
wonderful.
Venus. And we were
Yeah.
able to track down Venus, and then we were able to hop over to Jupiter, which is only
Yeah.
a few degrees
I mean,
away.
I only observe it when it's east of the sun. I I think that's the rule. Is when it's chasing the sun.
Well, if you set up in the shade of a building, you can do it on the other side of the sun, but you got to be really careful. Yeah.
Yeah.
No, we got a good look at it that day, and I once I got sight of it in naked eye, then it was easy to find.
I think Saturn would probably be visible.
Really?
If you were at high enough altitude and had a dark enough daytime sky, then Saturn would be visible too. But I think it's mostly just going to be Jupiter and Venus, Mars maybe. But I don't know. Mars is getting pretty dim by the time it gets around into the daytime sky.
Well, Venus Venus was really interesting to the naked eye because it looked just like a tiny moon in coloration. It lost all of its, orange coloration in the daylight, of course. It's washed out. So it looks like the consistency of the daytime moon.
I think one of the cool things about Venus is the hunt. It keeps moving. It's never in the same position with respect to the sun or anything else. And so it's a challenge to see if you can figure out where it is and track it down by measuring with your hand how many hand spans away from the sun it might be, and see if you can track it down. Once you've got it, it's like you spend 5 minutes looking at it and you're done.
Yeah. Really cool. Thank you, Bern.
Thank you again. Thank you.
Yeah,
Those are
thank
cool.
you, Bernie.
Yes, thank you.
It's always great having you. Well, did we want to discuss Dan's news too?
Oh, we could, but we're an hour and 45 minutes in.
It's up to you guys.
Must have been in meetings the rest of the day too, but
I don't have a life.
I will take any questions for sure. And you guys certainly know my email, but yeah, this is right now. We're just to summarize, we're in the wait and get funded part. And once funded, then we'll actuate our timeline sort of based on, those incoming dollars and, have some meetings in advance with the Forest Service though. I think that email, the most recent one, Jerry, I forwarded to you, was an invitation to reach out to them locally there and just talk at least about location and curriculum.
Right.
That's my next, but certainly nothing like dates or plans. So that fear not, EAS isn't like jumping into outreach at the moment, of course. And so when we do, you'll be the first to know. We'll put it on the mailing list and we'll put it on the website and ask you all to spread the word. But in the near term, we're just excited to share the news that our project was funded in concept anyway, and then hopefully off to a good start.
I assume
Also some collaboration too.
Well, that's right. So yeah, I did drop the name of your club, Amy. You're the other representative. You're the conduit to the Mid Valley astronomers. Sorry,
But we hadn't really talked about it
Mary City
because it was still up in the air.
Right. No, and there's no formal ask of you guys at the moment. At the moment we're just waiting to. In fact, Randy, I've got to make sure I connect you with them because they have to have somewhere to send the money.
Send it to me. It's okay.
Send it to the treasurer. Cash. All right.
And I know we've got Mike here from HVA too. So I was just, if we asked you to come talk to our group, would you be cool with it?
Yeah, of course. Is there someone on the call from Heart of the Valley?
Yeah.
Yeah, because I shamelessly
Mike, you're still muted.
plugged you and mentioned that, depending on the scope and where
There you go.
our spot is, we would certainly ask for support from Heart of the Valley astronomers as well, as in the form of docents and hosts at these events. I think what I signed up to promise was something like 2 or 3 events to try out, and then a series of them in a planned curriculum in the years to come, and staking out a spot and working out the idea of a visitor center. To be honest, in all honesty, a visitor center with a gate and like a warming hut. But in the near term, just a parking pad with a podium and some discs where we can set a series of pads, astronomy setups. So we'd be asking, we'd probably be having anywhere between 4 and 7 host astronomers, 4 or 8, I don't know, something like that. We don't need, I imagine our attendances to be in the order of 50, right? Because it's a place that people are going to have to drive to, and we're gonna have to pick our location based on where so many people can drive and, co-host with the Forest Service and so forth. But anyway, so we would ask for the engagement and collaboration of you guys, certainly, in these upcoming outreach events. But it's not like it's happening in February or March. But right now, it's scoped. It's scoped for the summer, and certainly the planning activities with the Forest Service will begin before that. And so we'd love to maybe check in with you offline and see what you thought about some ideas we had for. We want to first solicit them for their ideas about the nocturnal ecosystems of the Pacific Northwest. And we could even talk about our own experiences being, strafed by nighthawks and bats and so forth. But, build a kind of a curriculum together where there's a deep sky observation part that's, complementary somehow to their forest outreach piece. But we'll find out what they'd want to say. All I know is they got really excited about it when I ran the idea past them. And so I'd like to hear, I want to make sure that I keep it Forest Service first, so that if money comes from them. And so let their, maybe they'd want to have us host events around a nearby clear cut to celebrate the importance of clear cuts. I don't know. But clear cuts are great for observing, right? Those are the locations we seek out. So we could highlight that as a multi-use area thing. And so ours, by the way, in $2.5 million of dispensed monies, ours was the only one that had an outreach component. And I think that's the only reason we got a nod. Outreach wasn't really the big scope. The big scope of this dispense was around maintenance of trails and maintenance of invasive species and Forest Service concerns. So I don't think we were, unwelcome, asking for some of the cut from these funds. The Forest Service was excited to hear from us, and so we'll be following up with them.
Mike, did you have any questions or comments or anything as president of HVA?
Okay. Hey, well, yeah, actually, Dan, I mean, it'd be great if you could come to our, maybe our next meeting. I don't know if that's possible, but we meet the second Tuesday of every month. Similar time frame as the EAS meeting, only on Tuesday. If you could come and kind of give us the details of what you're thinking, what role we may be able to play in partnering with you guys in this effort.
Great. No, I'd be happy to. I've tuned into some of your calls already. And I think what I would do is just give the same little slide deck I gave at the beginning of this. And then, I mean, any specifics are really just going to be about, hey, we need 2 people with telescopes for an evening on this day at that time.
Gotcha.
Location.
Yeah. But just to explain, I'm sorry, I came in late, so I missed your presentation. Sorry.
Oh, okay. Yeah, then I'll definitely forward that to you. And no, I'd love to share with you guys. So you're the second Tuesday of the month. So we've missed this month, but February would be the
Yeah, that's what I was thinking. If that's possible.
Yeah,
I'll make
I'll
sure
look you up, Dan.
thanks, Amy. No, I'd love it. Thanks. Again, it's just something where, especially if we put our heads together and we decide that, hey, there's a site with a lot of attraction appeal to, say, nearby campsites or even a town, but it's still in the so-called, it doesn't have to be in one of our pristine zones. We recognize that we're not going to be able to reproduce a site like Linslaw or the Eagles Ridge Amphitheater, areas in darkness if we're going to host events. But I think together we can probably, especially with the Forest Service, this is the other thing that what I really want, and is the buy-in from the man. So we can do what we do legitimately. So we can actually work with the purview of the landowners whose place we otherwise just sort of impinge on. It'd be great to actually have a dedicated spot. And so if we lose a little bit of darkness, we can still discuss, a great deal about the importance of the darkness to.
Yeah.
Well, anyway.
There's Lori was also asking what did you hope to do with more money and why did they deny it?
Oh, no. So the money was for gravel. What I was proposing is we identify one of our smaller sites and pour a whole bunch of gravel and level it and make a bigger, easier access. And so it would have been sort of this several phase thing where we identify site and then not a major improvement, but just, most of the places we visit, we all know, just need leveling. And so leveling of a relatively large area. And so we just sort of, and back of the envelope came up with numbers for what it would cost to pour so much gravel in such and such an area to accommodate, something like 25 or 30 cars and something like 50 odd people plus us and the Forest Service. So, but the idea would be like a parking area, an amphitheater area, and an observing area. So that's what the ask was for. And I think that would be a phase 2, is to actually do that, to get the permission to pour the gravel and so forth. But that implies a phase 1 where we identify a good site and show we can work together and have a, see if this thing kind of works. If we put up somewhere near Jesse Honeyman Park and we draw a whole bunch of people out to learn about not just the night skies, but to learn about the forest from within the forest. I kind of like the idea of calling it a forest observatory and, deep sky and dark sky park. The Siuslaw National Forest Observatory and Dark Sky Park is
It's also suggested reaching out to Night Sky 45 as well.
Yeah, but the thing is, I want to be careful. They were careful to warn me that we didn't want to name it a preserve or name it any kind of like, the Forest Service has a lot of land use out there. And so there are many people on that call. Many of them were forest, there were loggers and people who control water and, all sorts of stuff. So
there's a lot of political work.
Yeah. So we're asking for relatively small potatoes, but the outreach part, I think, is something we can really hone in on. And I got to say, outreach would be, it'll be, I can't wait to do it. And so whatever format it takes, it's just another way that we can, get re-engaged once, I'm not saying things are going to like suddenly wide open happen, but I'm sure that outreach will resume in some capacity.
One of the things that we talked about, one of the advantages of doing this with the, under the purview of the Forest Service, is that it could become nationally known. It could become a tourist destination.
Yes.
Like a dark sky park. There are several places already that have that designation. And
people come.
Yeah, and we've got tourists driving up and down the coast all the time. And if it's an easy drive into the mountains from Florence, say, or from Waldport or wherever where tourists are spending the night, they could just come up for an evening. And if we did this, a couple nights a month, it could become a fairly big deal for the tourist industry. Probably not like millions of dollars in it, but it could be an added draw to this area. And I think that's what the Forest Service is kind of excited about too.
Yeah. Multi-use, and multi-use was one big thing that really resonated with them. And then just what Jerry said, the idea that it becomes a draw in and of itself. But just this, the seed, just testing the seed of the idea, just to, hey, will people come to our astronomy event? If we advertise regularly at these campsites or some targeted areas around the sites we pick. I imagine we won't have a hard time getting engagement. But the Soyuz law, of course, goes as far. I think it's not all the way to Lincoln City, but it's certainly within shot of your areas, and
Right.
but it's right in the middle of where we typically go, outside, just past Mapleton.
Really?
And you mentioned that it wasn't just an astronomy thing, at least from selling it to the Forest Service.
Yeah, I wanted it to be a
Also,
forestry thing. So if we sort of lead forestry and then say astronomy is just the draw, it's a star party that also, our message is just about the preservation or the importance of the dark skies, right? You can just say, like, these are the things you can see when you aren't in the city. And then their message is, of course, these are the animals and the creatures and the ecosystems you don't see because it's dark outside as well. Usually the program when you go to a Forest Service campsite is the raccoons and the falcons and things like that. This would be an interesting take on it. The nocturnal ecosystem, I think, would be a really fun thing that they'd want to engage on. But I don't have to prescribe what they would put in their program. They can say what they like. But we'd be sort of just capitalizing on their, they've got sort of a captive audience in their, various campsites and so forth that I think we could appeal to. And I think we have a cool thing to do, that people would drive, 20 to 40 minutes from wherever they are.
Hey, Dan,
Yeah.
the place that comes to my mind is Mary's Peak, and the guys up in Corvallis probably know more about that.
Can it accommodate some? Yeah, it can accommodate some parking.
There's already a huge parking lot on the top. So there's plenty of parking. In fact, a long time ago, I used to go there a lot, doing some stargazing on my own, but pretty much in those days, I was the only person there in the middle of the night. It was great, and it's dark.
Is it in the Soyuz Law National Forest?
Good question.
Yeah.
I think so. Yes, it's right.
Yeah.
Yes.
Excellent. Okay. Well, yeah, no, that's so that's the kind of thing, I just wanted the first conversation with the Forest Service. I would like to include, I would like you guys to be a part of, so we could, first of all, just sort of collectively put our ideas out there, or even, I don't know if it's like looking at a Google Maps with them, or if they've already got, I imagine nobody's going to have better knowledge when we say, like, hey, these are the characteristics of a good site for visual observing it. We'd ideally like, southern and eastern exposure with, some like hills in the way of the nearby light, and, like that. But it's not like I imagine this will like jump immediately to their mind, but our president on the call has already, he's got a nice list of, he spends a lot of time on Google Earth perusing potential sites, and we've driven out to some of them behind chain link fences and stuff. But I like the idea of just, first just identifying spots with them. And so you guys must have your own spots that you like there, and
it's something that definitely should be discussed in length.
yeah,
We usually go to Adair County Park but right now we're relying completely on virtual star parties.
oh yeah.
So, I mean, with Omicron and COVID still raging, it's I don't know about meeting with the public yet.
No, I don't think we'd be doing that at all.
Yeah.
Certainly not. We're not even funded until sometime in the summer, I think, is when the funds disperse.
Okay.
I was just announcing that we applied for and got this grant for outreach.
Wow,
so.
cool. Okay.
We're excited. It's a ways out still.
All right, congratulations. Good job.
Oh,
Good job, Dan. Thank you.
Thank you.
thanks to everyone. And also one of the unsung, people not on the board, who's on the board, but Robert Asamendi, who gave us, another couple of paragraphs of the content as well as the slides with all of our nice graphics.
It was mostly Dan.
Well, yeah, it'd be you. We'd be turning to do the media blitz for any of these things. We'd make similar flyers and just staple them up at Jesse Honeyman Park or Beverly Beach or the campgrounds up and down the coast. And
Yeah, it's going to be awesome.
I think we would get a fair draw. In fact, I'm sure we'll get an excellent draw. I do a lot of camping there, and this would be a really cool looking thing.
Nice.
Robert, you got some cool
By the
head
way, Robert.
Thanks.
Thanks, Amy, and the rest. I need to move on and hope to be able to present again. I've given
Trust me.
a couple of ideas.
Thanks, Bernie.
I'm very, very happy. And again, thank you all for allowing me to speak. Thank you.
Thank
We
you,
will
Bernie.
definitely be roping you in again.
No, I'm gonna follow Bernie out the door. 2 hours is
Yeah.
Yeah.
already.
All right.
We'll see you all.
So, hey, Dan, we'll be in touch.
Thanks. Good night.